Hello, everybody. Today I'm going to teach you about the concept called exception handling in C++, which is our last topic in our syllabus. So this is very important actually. This helps. This particular exception handling concept helps us to detect, handle, and recover from runtime errors. Like normally when you run a program, when during compilation you won't be getting any errors. I mean, but there are more chances where you get errors when you're running the programs, or what to say, like even there might be other events might happen. Okay, that those things I need to handle. We need to handle so that the program should not crash. Because if the program is getting crashed, automatically it affects the business, it affects the productivity. So those runtime errors must be handled. At the same time, program must not be crashed or it should not be stopped. For that, we have a concept called exception handling. So that we are going to learn today actually. So there is a specific logic included with respect to exception handling. We call it as error handling logic, which is not same as like program logic which we write. There's specific logic written to handle the errors. So ultimately, we use this to ensure reliability and readability of the code. So to tell in simple words, the errors caused during runtime should not stop the entire solution or entire program. That's the purpose of exception handling. So it might happen if the program is trying to divide by zero, like if a denominator is zero. So rather than the program getting crashed, I can handle that exception. That error is called an exception, right? And also I can display a proper message. So this is called, first of all, this divide by zero, I can call it an exception. And also in another example, if a file is not found, okay, those can be handled. That is called an exception. Logically, the program is not wrong. But during runtime, this could be giving us an error that is called exception. So I should handle using the concept called exception handling. So if I don't have exception handling, there are more issues I'm going to face. It could be the crash. Okay, and the user will not be able to get any feedback or what's happening. So exception handling helps to provide that, and so many other benefits. Mainly, it provides meaningful messages and other things. So I can show an example by running. Uh, for example, I have a program here where I'm running a simple division program where I'm running. I'm giving a normal input, so fine, no issues. So there's an issue. Just wait for some time. Yeah, let me copy this program. This is the program I have. I'm copying that. I'm running this now. Now, if I give normal values, fine. No, it is giving the output. But if I'm running with the denominator value of zero, normally, if there is no exception handling, the program will definitely crash. But here, the program is not getting crashed. At the same time, the user is getting a feedback. You can see there's an exception caught. Division by zero is not allowed. So this is a kind of benefit we have with respect to exception handling. This is the output of this program. So let's see how this program is designed to handle exception with a simple logic. The solution is very pretty simple solution, which is just a division, but the main focus on dealing with the exception. So as usual, we have the packages and other regular things which we see from the first program, and there are two variables we have A and B, and we are going to assign assign values for these two variables by getting input from the user, which is happening over here. Now, to handle the exception, few things are essential. And those things which you feel there might be a issue during the runtime, those must be handled, must be kept inside a block which is called try, and the try must be followed by catch. This is the way of handling exception concept in C++. Now the b is the denominator. What I'm doing is if b is equal to 0, I'm checking. So obviously what I should do, division by 0 is not allowed. It's a feedback I'm going to give if this condition is satisfied, and that is being thrown. I use a keyword called throw, and that is being caught by a keyword called catch, and the information is received through E, and I'm displaying the feedback to the user exception caught, and the value which is stored in E is displayed. Fine. So if this will happen if B is equal to 0. Otherwise, if all fine, if B is not is equal to 0, so automatically I'm going to get the result. So I'm going to get the result actually. Then this is going to be printed. So this is how the exception is being handled. If I run again with the proper values, so I give 10 by 2. So you can see that this line is getting executed, and also finally this line is executed. At the same time, if I'm running with the denominator 0, so you can see this line is executed. Okay, this line is executed, and the information is actually thrown by this keyword because of this exception. So you can see the difference. So this is the main advantage of using exception handling. Even if the input is wrong, logically, if it is wrong, okay, syntax wise, it's not wrong. Logically, if it is wrong, still the program continue without any crashing. This is the advantage of exception handling. So this is the thing, the explanation, whatever I told is given here with the sample output. You can also try. This is the program which I copied and I was explaining by running. So this is all about exception handling. If you have any clarification, you can raise, queries through GCR or send me an email. Thank you.